Another important concept in stoichiometry that we will apply many times in our problems is the reaction yield. The reaction yield is when reactions do not give the 100% of what is predicted. And that's a very realistic view on reactions because practically there is no reaction that gives the 100% of what it's predicted. There's always a side product, as shown here. So it was a side product, or maybe the product escapes the container, or for whatever reason we collect less product than what we would anticipate or what our equations would give us. So we talk about percent yield as for the amount of, so typically it'll be the yield can be in moles or it could be in grams. So if it's percent yield in moles, would be the moles of product obtained over the moles of product predicted by stoichiometry, and that is multiplied by 100. The percent yield in mass, of course, it would be percent yield in mass. It would be the same ratio, but in mass. Okay, so it would be the mass of products obtained over the mass of products predicted. Hopefully that makes some sense. So let's just run an example to see how we can calculate yields. In this case, we are mixing, again, it's the same reaction, but careful now, we are mixing equal amounts of moles, not grams as the previous example. We are mixing 10 moles of hydrogen and 10 moles of nitrogen, and it says that the reaction yield is asking for what the reaction yield is if we obtain 5 moles of ammonia. First of all, the first step is to figure out which of these two is the limiting reagent. In the previous example, we saw that the limiting reagent was nitrogen. However, that is not always the case. It's the limiting reagent will depend on how much of each of the reactants we mix. So let's do that. Let's calculate if I have 10 moles of hydrogen, how much ammonia can I make? So 10 moles of hydrogen. The recipe, the balance reaction tells me that 3 moles of hydrogen react and give 2 moles of ammonia. 2 moles of ammonia. Okay, so that's 10 times 2 divided by 3. That's 20 over 3. So that is 6.6. Okay, 6.6. Okay. Okay, so let's see if nitrogen is the limiting reagent again. So the recipe says that 1 mole of nitrogen will react to give 2 moles of ammonia. Again, this was moles of ammonia. We're calculating moles of ammonia. This is 10 times 2 divided by 1. This is 20. We get more here. We get less here. That means we will run out of hydrogen first. This is our limiting reagent. And this amount is the one that we will use to calculate everything else, to calculate leftovers, which is not asking the leftovers in this case, but there will be 0 moles left of hydrogen, and there will be, in this case, right, we could calculate that, but we're not going to do it. Just look at the previous example to do it. It's asking for the yield. And the percent yield, and we're going to assume the percent yield in moles. If it were in mass, we would need to convert that in mass, but the percent yield in moles is the mass of product obtained. That's given, okay, in the question. There was 5 moles of ammonia obtained. How much did we predict? As many as the limiting reagent dictated, 6.6. Okay, and we multiply that by 100. So this is 5 over 6.6 times 100. That's our percent yield. Notice that is less than 100. If your yield gives you more than 100, it's a wrong yield. Okay, hopefully that makes sense. You cannot obtain more more product than what you can predict. Where would it come from? You can understand that there may be some side product, there may be some loss of of reactant and product going elsewhere or becoming something else. However, you cannot obtain more than what you mix in. Okay, hopefully that makes sense. It definitely requires a lot of practice, but hopefully this example may help you start practicing.